Hello everyone. In this particular lecture we will be discussing about raster data compression techniques. We will be also seeing that why data compression is required and various types of data compression techniques which are relevant in GIS or in digital image processing. So we will be discussing all those here. First of all, why data compression is required. As you know that in case of vector data or in 10 data, there are hardly any redundancy, and therefore data compression has no role to play basically. But in case of raster data, for example like satellite images or in digital elevation model, might be having lot of redundancy. Redundancy means for large area the same value is being repeated, and therefore by some means we can reduce the requirements of data storage, because raster occupies large space in hard disk as compared to vector data or 10 data. Those data are very compact data models, but raster is not in that way, is very compact data model, and therefore data compression techniques have been developed, are being developed. Many are in public domain and many are copyright protected, but still some of them we can use it. Two major types of database techniques which exist. One is we can say that they are non-destructive raster data compression techniques, and another one is destructive raster data compression techniques. Let us take the example of first non-destructive database raster data technique. Is that in that whenever you are say having a satellite image, you compress it by that particular tool or compression tool, and then when you want to see the original, you can reach to the original quality or original size of the image without compromising on the quality of the image. So this kind of technique is called non-destructive. Example is like with TIFF images, you can have a compression which is called LZW. We will see in little later in detail what is LZW, and using this tool or technique you can compress your TIFF file, which is a raster file or image file. Now whenever you want to decompress it or uncompress it, you can reach to the original. And there are non-destructive or there are destructive image process raster data compression techniques are like JPEG. JPEG is a file format as well as a compression technique. So if you have converted your file, say originally it was in TIFF, you have saved as JPEG, and later on you have deleted the original TIFF file. Now you want to restore to the original quality, you will not achieve. However, there is a trade-off. JPEG will provide a quite high compression, whereas LZW in case of TIFF, which is non-destructive, may not provide that kind of compression. So many times there is a trade-off. You achieve high compression and but you lose the original quality of the image, or you cannot restore to the original quality. So these are the complications which are there in case of raster data compression techniques. Now as we know that raster is stored in rows and column, is a two-dimensional matrix that we have already discussed, so we will not go in this detail about what is raster. Now let us take the real example, which is very simple example I have taken here, is a 16 by 16 binary image, and in one area which is shaded here, say it is black, though it is appearing as gray, just to keep these the grid lines appearing, therefore it is deliberately kept in gray. Otherwise assume that this is a binary image, some area is homogeneous, there are no other values except the say white, or here the values are black. Now if I want to compress this kind of image, then there are four basic compression tools which have been implemented into GIS and image processing softwares, and every time whenever you go save as and some options, you would find these details are available, and sometimes when you are using such software you do not know why such options are available. So many times now when now later on when you will use or understand all these basic compression techniques, then you would know what is the meaning of those options are. So here I am taking this. So first I will go for chain codes. So if I have to one type of data compression technique, so here what I will be following a concept which is something like that for if I move my cursor into the north direction, I will use one value. When I move to the east, this is 0, and then to the west 2, and then for the south it is 3. So likewise the coding can be done as per your convenient, but if that is the coding which is written here, if we follow, then this entire shaded area can be stored quite easily following these codes. So we start, because our data is starting in the first column and 10th row. So this is stored as that first we move towards the east direction, and this is not arithmetic, these are the codes. So there is no meaning of that like 0 square doesn't have any arithmetic meaning. These are just simple codes. So we move our cursor one pixel towards the east, and east has been coded as 0. That is why 0 is coming first, and then one pixel up, and therefore towards north we have given 1 code 1, so 1, and then 2 pixels towards the east, so it is 0 square. And likewise we come at the end and then go from here 1 cube. So we reach to the original position, and this is how this entire image, otherwise it would have been stored in 16 by 16 pixels, can now using chain codes can be stored by using just these simple codes. So because a simple example, a binary image, so either one area we will store. So because this black area, shaded area is smaller, so it is better to store this one. So by following this chain code concept, we can store that entire image using only few codes. There is another technique which is called run length encodes, or sometimes it is written as in many softwares and elsewhere it is also mentioned as RLE. E here instead of code it stands for encodes, so that is why E is there. So run length encodes or codes are there, as name implies that along the length we run and count the number of pixels which are coming or cells are coming. So run length codes allow points in each mapping unit to be stored per row in terms of left to right of a begin cell and end cell. So let us see how this image can be stored. Like here, because up to row 8th nothing has to be coded, so that is not recorded. Now 9th row we are having first a white pixel and then we are having black. So we store only starting from black 2 to 3. So this is length has been stored at row number 9. Then row number 9 again a length has been stored, and only single pixel is there, so 6 to 6 only one pixel, then there are 3 pixels, so then 8 to 10. And likewise for each row wherever we are having this black pixel or dark pixel is stored, and till we reach to the end of the image, which is the last row in this case, and last row column number 9 to 11. So everything is stored, and first it is searched and stored, and therefore instead of storing again 16 by 16 image, you store only using these codes. Now the third basic category of data compression technique is called black codes. That is, the idea of run length codes can be extended to 2 dimensions by using square blocks to tile the area to be mapped. Here first the search of that shaded area is done. Largest squared block has been searched here. In this example, which is shown here in the blue color, is the largest 4 by 4 pixel largest, which is having homogeneity. So first this is coded, then next is smaller, then 2 by 2 is coded, which is shown in red color, and then finally you reach to the 1 or unit level, that is 1 by 1. So, there, as name implies, first you search the largest one, blocks, block by block it is stored. And if I have to data structures in black codes consist just 3 numbers, the origin, the center or bottom left. So, we will store from where this block is starting and what is the dimension or radius of each square or size of each square. So, if I have to store that particular image, the binary image of 16 by 16 pixels, then only in this particular example only 3 things have to be stored, that I am having one square of 16 pixels and then I am having 9 squares of 4 pixels and I am having 17 squares of unit level, that means 1 pixel each, and therefore the entire image can be stored by using certain codes, and it is quite efficient. Larger the square can be benefited or fitted in the any given region, and the simpler the boundary, the more efficient black code becomes. So, if your data is having lot of redundancy, that means homogeneous areas, large homogeneous areas are present in the data, then you will achieve very good compression, and these techniques becomes much faster, especially about block codes. Now, the last in this basic types of raster data compression technique, which is this technique is very popular, and there are various variants of this technique also exist, like instead of quad trees people have also developed octrees and so on and so forth. Here this technique initially is not simple, but it provides quite good compression. So, what it is done in this technique is the first this entire image is searched. In this example very carefully I have taken a binary image first. In real scenarios you will be generally you may not be having binary image, you might be having colored image and 24 bits image or 64 bits image. So, the complications will be much larger, one. And second, in this particular example I have taken a squared image, and therefore to demonstrate the quadries concept it is easier, but when your image is not square, what would happen, that scenario we will also see. But anyway, so let us start with the coding this one through using the concept of quadries. So, first the search is made, and then 4 quadrants, the entire image is divided into 4 quadrants, and then each quadrant is further searched. If homogeneity has been achieved within that quadrant, then no further divisions would be made. Like in this example, the quadrant number 0, and now there is no heterogeneity is there, everything is homogeneous, all pixels are having same value, and therefore no further divisions for quadrant 0 is required. Same is in case of quadrant 1. Let us take example of now quadrant 2. In case of quadrant 2, there is a heterogeneity exists within this quadrant, and therefore more divisions would be required. So, first again this quadrant 2 is divided into 4 parts, then again search is made. So, if we follow this 0, 1, 2, 3 code system, then again this is 1, and we will code as 2 1 2 0 sorry 2 0 2 1 and 2 2 and 2 3. So, now this quadrant 2 2 has is still having some heterogeneity, and therefore there will be further subdivisions till we reach to the unit level. And as we can read here is that quad 3 method is more compact representation, and therefore it provides high compression compared to other discussed compression techniques based on successive divisions of 2 power n by 2 power n array into different quadrants. And if I take the example here of quadrant 0, then how for each pixel is coded. So, this is the largest quadrant is 0, 1, 2, 3. Within this then divisions have been made, and this is the 0. So, it becomes 2 0. Now, 2 0 is further divided into 4 quadrants. So, this is 2 0 0 and then this 2 0 2 0 1 0 and so on so forth. But let us concentrate on this one. This is 2 0 0 1. So, likewise for each pixel a code is given, and whereas when we do not have any divisions or homogeneity is there, no further codes are assigned and no further divisions are made, and therefore it is very compressed method and provides good results. Let us the same thing I have coded here for different pixels, and as you can see, this is how it is seen. Now, why it is called quad tree? Because it is an inverted tree basically concept wise. So, you are having one root, one image, and then it is divided into 4 sections and 4 quadrants, and then homogeneity is such, if homogeneity is achieved, then go for next and go for next and likewise till you reach to the unit level. In earlier example, I have taken an image which is 16 by 16 pixel, that means a squared image. But if you recall that when we were discussing about raster data, the overall shape of raster can be either square or rectangle. However, the unit of the raster has to be in square in shape. So, if we in the previous example I have taken raster or an image, binary image of a square shape. Now, let us take example of real map which is not in a square shape, which is in a rectangular shape. So, what would happen in case of quad tree? So, this is how what it is done before the quadrant are searched. First it is searched whether the input image is rectangular or square. If it is rectangular, then on the sides few rows, blank rows are added, columns are added, and the entire image is made in square form, and once it is in square shape, then divisions will start. Like here it has happened. So, the quadrant 0 is going beyond the boundary which are shown here. So, you have to imagine that quadrant 0 is much larger than what is shown here, and it has to be square in shape, it cannot be rectangular. Same with the 1, because the quadrant 3 is not sufficient here. So, it has to go on the right side further, and likewise, but if I have to code this map using quad tree concept, that this is how it will be done. Same scheme we follow 0, 1, 2, 3. Now, the quadrant 2 has been further divided, and the boundary is here between 4 basic quadrant. So, it is 2 0, it is 2 1, 2 2 and 2 3. Now, 2 0, 2 2 and 2 3 and do not require any further divisions, because homogeneity has been achieved. Only 2 1 requires further division. So, then again further divisions 4 quadrant were created, 2 1 0, 2 1 1, 2 1 2 and 2 3, and we have reached to the unit level. Now, no search, no further divisions are required, and by which you can achieve the high compaction of the images. And this is how, if we want to represent a form of tree, then this is how it should be represented. This is 0 1 2 3, 3 should have come here, 2 0 2 1 2 2 and 2 3 should have come here, and likewise. And in a tabular form, if we want to understand, this is how the coding is done. So, an image, whether it is square in shape or rectangular, still it can be coded using quad tree. In case of octree, instead of 4 divisions, you make 8 divisions, but the concept wise it remains same. There are hardly much differences in the results. Now, as I have said that the very popular your image formats like TIFF or some other image formats are also supported with some compression techniques, and one of the very popular one which you would find these options whenever you save your image or save as, you go for another format, then sometimes these options are available, and that would you like to save your image with LZW compression. So, what is LZW compression? This compression is of course the purpose of all compression techniques to reduce the file size, but at the same time you have to choose whether the Later on, if I want to restore to the original size and quality, I should be able to do it or not. That is very much important, that is very much required. Now LZ is based on the three mathematicians who developed the algorithm, and their surnames first character has been taken. So Abraham Lempel, Jacob Ziv and Terry Welsh. So these three people, their surnames have been taken, and LZW. So they developed basically the algorithm of which is became very popular to compress your GIF images and TIFF images. GIF images are mainly used for animations. I will show you little later some examples of GIF images, how they can be compressed using LZW, and how animations can be created. Further, that LZ also suitable for compressing text files. Generally text files do not have much redundancy, except when we type a lot of space in the files, that may create lot of redundancy even in text file. So LZW can also be applied there, but most of the time compression techniques we go mainly for raster data compression. However, there are many other popular compression tools available which we use in our day to day usage of computer, like WinZip or RARZip. They compress each and every type of file, but all details how they compress are not available to us. So that is beyond a discussion of this lecture. Now LZW compression takes each input sequence to a bits of given length. For example, 12 bits creates an entry in a table, and then dictionary, then code book, because everything is coded, and as in other examples we have seen, and then we read this thing, and this is the LZW is non-destructive. That means you can restore to the original file size and quality without compromising on the quality. Unlike earlier approaches, there are different versions of LZW, like nowadays different versions of JPEG files are also available. So they are further improving on the compression, and sometimes what happens that if you have compressed with simple LZW and later on you are using some other tool, you may have the difficulties. So it is again trade off. If you go for the lowest compression option, at least you will not have problem on other systems, or if you give the file to somebody, he might not be having problem. So these are the things before compression one has to think. Decoding programming that uncompresses the file is able to build the table itself by using algorithm. It is possesses the encode input. All these LZW compressions have been implemented in all well-known GIS and image processing softwares. Most popular one is JPEG, and unknowingly people are using JPEG. Unknowingly means they do not know that this, though it's a image file format, but it is a compressional tool, data compressional tool, and what it does, it destroys the original image and quality as well. And you can compare by if you zoom a TIFF file and the same file, if you save as JPEG, you zoom side by side at the same level, you would find the quality has deteriorated, but it is a trade off. That means a compression through JPEG will provide high compression. A 10 MB file may be reduced to 1 MB file depending on file to file, because if redundancy is high, then you will achieve more compression. But the disadvantage is that it deteriorates the quality. So it is providing you high compression, but at the same time it is deteriorating the quality. And lot of people unknowingly are using JPEG format to store their original files or original images, original photographs when they take digital photographs. So they are going for higher and higher spatial resolution digital cameras, even in their mobiles or otherwise, and the original files they are storing in JPEG. Though they are storing more images, but at the same time they are reducing the quality of their images. So there is again trade off, that rather than storing files in JPEG, originally one should store in TIFF and later on you can compress. So, you will have two sets of files, one is in TIFF and one is in JPEG. JPEG will provide high compression, but TIFF will have the high quality. So, unknowingly, that is why I said that people are storing data in JPEG without knowing that they are losing the quality of their photographs. JPEG again is a group of people which is a joint photographic experts group. Different versions of JPEG have also come, and these still are being developed, and because it provides high compression and therefore it is very popular among people. People have followed certain standards and other coding are also available. Then there are together with JPEG and this you are GIF and PNG, and that is portable network graphics files. The JPEG is one of the image file formats supported on the World Wide Web. Because on net it is very popular, that is why people are going GIF for animations, which I will show you little later. Now, GIF is a graphics interchange format, and here what you can do, you can keep a lot of frames in one like a movie, and then you put in a one file by using certain tools, GIF creators kind of tools, and then GIF file is created. That is also a compressed format and it works very well on any computers, and it is very easy on internet as well. That is why a lot of animated images on internet you see generally they are in the GIF format. And the example which I am going to show here, it is having 8 frames in a one GIF file using a tool, GIF creator kind of tool I have used, and all input images had the same sizes except that files inside are different, and it is showing a sort of simulated animation, and the position of sun is moving at different locations and the same terrain is looking differently. The purpose here is just to show the GIF file, but not the what basically it is showing. That is a discussion of another lecture. Another example of a GIF is here the sun is coming from almost 5 degrees above the horizon and going overhead and moving in a loop. So, one single file which is in GIF format can have animations, and that is the advantages of having animated files in GIF format. And you can put on your web page or you can give to somebody, and when they will open it, it will run exactly in the same way. Now, there are different versions of GIFs are available, and further improved versions are becoming available. So, it is quite good, quite popular for animations. Now, one more compression techniques which has become very popular nowadays, because it provides very high compression one, and it is non-destructive image compression technique, and that technique is called multi-resolution seamless image database, or MrSid in short we call. This has been developed by a company which is called Raster. The problem with this that we do not know much details about MrSid. This is copyright protected. Many softwares have implemented, but up to only a certain limit. For example, like in ADAS image processing software or in ArcGIS software, you can compress a file of only up to 500 MB. If your input file is more than 500 MB, then you cannot compress using this MrSid or option of MrSid. You have to buy then the permission or access through the company which is Raster. So, it is a copyright protected. What kind of compression it provides is very high, unparalleled by any other technique, because the technique which they have developed on is based on wavelet, and it provides about 50 times. That means a 50 MB file can be compressed to 1 MB, and then it can through net it can be transported or transmitted from one end to another very easily. One of the examples where MrSid format is being used extensively in like Google Earth. You know that Google Earth is having large sizes of image of of many terabytes, but on our machine, on our desktop, this comes very easily. And why it is so easy to see on our images, on our screens, because they are in the background, it has been compressed, and when you open in your machine, it is decompressed very quickly. And since it is non-destructive, so whatever it has been stored inside the system, same you are able to see it on your system. As you keep zooming, a different layer will come, and so on and so forth. So that provides a very high compression of about even up to 50 times. So a 50 MB image can be reduced to 1 MB without losing image quality. That means you can, this is non-destructive image compression technique or raster compression technique, and you can restore to its full quality anytime whenever you want. So that's the biggest advantage, but it is based on, it is copyright protected, therefore we don't know much details. Only thing that we know, it has used the wavelet technology. One example is also given that if you are storing satellite images in 40 CDs, then entire those images in MrSid format can be stored in one CD. Now the last thing which I want to discuss in this data compression techniques, this is not exactly a data compression techniques, but it provides a speedy display of your images or raster on GIS platforms or in image processing softwares. This is a concept of pyramids which is also followed in Google Earth, that what is done here, that it reduces the resolution at the highest level. So when you are seeing the entire globe, you are seeing at very low resolution. As soon as you start zoom in, you get the higher resolution image, and therefore there is a construction of pyramid. In these like examples of the software like ArcGIS or DAS imaging softwares, whenever you open a large file, it will ask you this option that would you like to construct a pyramid. And if you say yes, then what it will do, it will create 2 or 3 files on your computer, and those files will not be very large, very small space occupying files, and they will store this pyramid structure. So next time whenever you will open that file, it will not ask whether you would like to construct the pyramid, because it has already constructed one, and your display becomes much faster. And this is the technique, that is why I have put in a compressional techniques, but exactly it is not compressional technique. It makes your display very efficient and quite fast. So the pyramid has become very popular structure for representation, whether it is Google Earth or in your systems also. You can opt for this only once, first time you have to create pyramids, rest of the time no pyramids are required. If you transport the file from one system to another, then the original file plus these 3 files have to be transported together. Then you need not to again reconstruct the pyramid, and constructing a pyramid of a large image won't take much time. So it is very efficient way of displaying your data on your screen, and as you go high, as you keep zooming, you get the fine resolution data. Otherwise at the top of the pyramid, at the initial stage, you get very low resolution data from the same image. So that's the advantage. So thank you very much.